reducing point source data for NIRSpec IFU. There's the sort of import statements at the beginning, defining the convenience functions for plotting and showing images. The thing where we can set the JWebbinar keyword to true so that it's only looking at one exposure, and then for stage 3 makes use of all of the pre-processed data. And then these are the paths, input and output paths. And then CRDS information, background. In this case, for the point source NIRSpec notebook, this is observations of NGC 7319, which is an AGN from program 2732. And this is PRISM, using the PRISM disperser for NIRSpec. So that's the lowest spectral resolving power. I'm just sort of skipping the math step since I showed that in the previous notebook. And here's where we define processing for stage 1. And again, specifying keywords for the jump step, and ref picks and wrap fit and saturation like previous. And then ran the detector 1 step, and it finished successfully, and then plotting the results. So here's how PRISM data for NIRSpec appears. And here you're getting the entire 0.6 to 5.3 micron spectrum in these small segments. And so you see the top 15 up here and the bottom 15 over here. The PRISM dispersal of the fixed slits data here in the middle section. And then here's an inset at the beginning of the next to bottom of the slices. And so you can see that in the inset. And then the inset and the whole thing for the data quality for the same exposure. So you can see the bits in the data quality map. And then stage 2. So here we're changing the source type to point, because we know that this is a point source observation. And then do the stage 2 processing. So again, setting the different steps for stage 2, and the feedback, and this process successfully. And then the output from stage 2. So the images at different wavelengths, the spectrum or spectra at different positions, and then the weight map. And you can notice at the longest wavelengths, you're seeing the hexagonal pattern that you get, the diffraction pattern that you get from James Webb is sort of this characteristic hexagonal pattern that you can see at the 4.5 micron image. Okay, spec 3, the stage 3 part of the pipeline, again, requires the association file, so you can define that. And then here's how the output, here's how the association file looks. There's sort of the preliminary information at top, and then the individual exposures that are going into it. In this case, this is PRISM mode data, so the NRS2 detector doesn't receive light from the source, so it's not needed when you call when you list the exposures that go into it in the association file that go into spec 3. So it's just the NRS1 files, and using the underscore cal.fits. Okay, that's the association file, and now run spec 3, and again, being concerned about the outlier detection step, the cube build step, where we're again doing the modified Shepherd method here, different from the default drizzle, and then also specifying extract1d parameters like the IFU underscore autosend keyword. And then feedback from that, and that was successful. And then the output from that, so the images at the different wavelengths, the spectra at the different positions in the cube, the different spatial positions, and then the weight map, and again indicating that the center of the combined final cube makes use of more data than out towards the edges of the cube. And then the spectrum and the image, like a preview of the image. And I think here we go back and try specifying different values for the aperture photometry done in Extract 1D. So we're specifying the radius of the inner aperture and then the inner and outer radii of the background annulus. So we specify those here, and then we run the Extract 1D step that's part of Spec 3. And then, so that was successful. And then finally show the final output. So the original extraction here is gray, the reprocessed is the blue here, and then the then an image